So recently there's been a resurgence in interest in the KA24DE Nissan engine. Now, just a few years ago, everybody was pitching these things in the trash and throwing in an LS or an SR20 or something. But this engine's kind of like underrated. Everybody overlooked it. It's actually a pretty solid engine. We have a customer here that wanted to build a naturally aspirated KA24, and a pretty good effort. Maybe not a totally crazy one, but a pretty well warmed over one. And so here we are. Now this is going to be an NA SR, and one of the things is we run a higher compression ratio, and maybe we run a tighter center line on the cams. So those of you that ask, I want to build my engine now and put a turbo on it later, well, that's not exactly the best thing. Here's a turbo piston, and here's an NA piston. Now this is the NA piston for pump gas. It's California 91 pump gas, so we're keeping the compression ratio down to like 10 to 1. Our gas is horrible. Unless you live in California, you have no idea how bad our gas is. Like our 91's probably about as bad as your 89, or maybe even worse. I wish we could have 93 like a lot of you guys have, but oh well, that's our wise California government. Now, when you look at these pistons, the turbo piston has a quite a bit deeper dish, and the NA piston has a shallower dish. The NA is 10 to 1, and the turbo piston is 9 to 1. Now, if we built you a 9 to 1 motor and you're driving it around for, I don't know, until you could afford the turbo kit, it's pretty much going to suck. It's going to be slow, not get the greatest mileage, not be too snappy. It's a really low compression. I mean, it'll run, but it won't be the greatest. Now, if we built your engine with a higher compression, unless you're running E85 or something with your turbo, chances are you're going to be close to detonating, and detonation is death to your engine. So when you have your turbo, it's going to suck on the pump gas tune. And if you run E85, it's going to be sweet, but you're really going to have to run E85 most of the time to get the most out of it. So, or race gas. So that's why we kind of don't recommend, building your engine a turbo motor, run NA until you could afford the turbo. Just save your money and do both at once. Like you're going to have better results and be more happy. But like I said, this is a NA motor, reasonable effort. In NA motors, everything revolves around the head and getting good cylinder flow. Now the KA24DE head is a pretty good head. Stock to stock, it flows about 15 to 18% better than an SR20 head. So it flows about as good as a pretty decently ported SR20 head. It's bigger displacement, so I guess it needs the flow. But, there's other cool things about it too. Like it has a shallow included angle, pretty good quench, like centralized valves, and the ports kind of go straight in and out. So it's a pretty efficient head. Like the shallow included angle means it's an efficient combustion chamber. It's less likely to detonate. Good flame propagation. Those more pent roof chambers, they tend to detonate. Those are kind of more old school. This is kind of a newer design. And SR20 is like a deeper, more pent roof chamber, and that's why SRs have a bigger propensity to detonate. This chamber has decent quench pads. That's these areas right here. So as the piston comes to TDC, it kind of squishes the air-fuel mixture to a more central location in the plug. It also gives good turbulence, so you get a better burn. So it gets your charge where you need it for good ignition, better turbulence, better burn, less chance of detonation. It's all good stuff. Now for a mild engine like this one, or it's a little bit more than mild, what we did is we went to a 1mm oversized valve. We use SuperTech in all our valves. So we're running a nitrided stainless on the intake and a Inconel on the exhaust. We like Inconel on the exhaust. It's a engineering metal. It's an alloy of nickel, copper, and some other stuff, but it has excellent high temperature properties. Makes it great for exhaust valves. When you look at the shape of the valve, you notice that the stem is reduced in diameter toward the head. This actually helps the flow quite a bit. Like I think Speed Pro or somebody did some tests back in the early 80s, and on the V8, which isn't this, but they actually found about a 15% increase in flow. Now, I'm not saying it's going to cause a 15% increase in flow in this KA engine, but I mean, it's certainly not going to hurt. So you're going to get some flow gains. It's also swirl polished. Again, Speed Pro did some testing in the 80s, and they found a slight improvement in flow. That's really controversial. Like some guys have tested it and found that it does nothing. Other guys claim it does. I'm not making any claims at all, but it's probably not going to hurt. It's a pretty good improvement. Generally, the stem configuration. You also notice that the valve is kind of like a tulip shape. So when the flow is coming out of the combustion chamber into the port, this tulip shape helps the exhaust flow make the turn to the exhaust port, so usually pick up some flow there. One thing I like about these Supertechs is that they're forged one-piece design. Like a lot of other valves, even famous performance brands, the valve is two-piece, so you have your stem and your head, and the stem is spin welded to the head, which can be a really strong process, but somehow the engineer in me tells me a one-piece forge is probably even better. There's plenty of good valves made two-piece, but I kind of like the one-piece. That's just me, and I think I have pretty valid reasons for that, which I just said. The intake valve is stainless. It's nitrided. Now, nitriding is a really hard finish that penetrates a few thou into the metal. It's actually like you cook the valve in the mixture of nitrogen gas and cyanide and some really nasty stuff that probably isn't legal to do in California. But what it does is it leaves a iron nitride coating, which is like super hard, almost like diamond hard, and it's slippery. So you have this slippery, lubricious stem that's wear resistant and a wear and corrosion resistant face and all that. It's probably pretty good stuff. It's not like Inconel, but your intake valve doesn't need to resist the heat as much. Like the exhaust, it has a turn down stem for better flow. And if you look, it has more of a flat profile. Now, this flat profile usually helps the flow when it's coming from the port into the combustion chamber, and the flatness helps the flow, get out into the combustion chamber. So you have tulip on the exhaust, flat on the intake. That generally works better. Now, we go 1 millimeter oversized. It's just a slight amount bigger. What that does is when you're running your valves and they start to wear, the valves start to sink into the seat. Now, if we're to run the same size as stock, our valve would be low. But I like to have our valve job up high and the seat up high. When it's up high, that really helps your low lift flow. Makes a pretty big difference. And you kind of start off like how the head is brand new with the valve up high and not sunk down to the seat. And low lift flow is usually, what gets you power, gets you torque, and has really no negative effects. So get all the low lift flow you can and get the nice high seat that's not shrouded. And that helps your performance quite a bit. Since the valve is slightly bigger, we unshroud it at the edge of the chamber a little bit, probably about 1 millimeter, so you don't have any shrouding. Shrouding is when this wall here is really close to the valve and it kind of inhibits the flow out of the valve. So we just lay it back just a little. Now for the valve job, for a regular, not too crazy performance, we use a Newen valve job. A Newen machine is a CNC machine. It's not like a traditional cutter like a sturdy machine. So a 30, that cutter does 3 angles. You guys all probably heard of a 3-angled valve job and that being good. Well, a new one, being a CNC cutter, makes a continual smooth radius from the combustion chamber, cuts your 45 seat, and then makes a nice radius going into the port. And when you see this, it actually opens up the throat of the port and matches the port to the valve seating surface. So it's actually like pocket porting. So it does more than just cutting your valve seat. It actually smooths the flow into the entrance of the port. And we find that this is usually good for quite a bit of power over stock. You know, in some engines, we've seen up to 50 more horsepower. Now I'm thinking on this engine, probably 8 to 10 is probably a safe estimate about what we would get. And for like a semi-mild engine like this one, that's probably enough. Now, if you wanted to go for a little bit more, like I said, NA engines, it's all in the head. We can have your head hand ported, but you know, this is just hand porting, kind of common sense stuff where we open up the bowl, smooth out the short side radius, and clean up the throat of the port. Now that can be done for probably like about $1,000 or something, and you know, that's probably all I recommend unless you want to be spending a lot of money. If you wanted to spend a lot of money and you know get everything you could NA, like we can get an outside consultant to actually do some flow bench testing and develop the head, but you might have to sacrifice a head for your development, you know, like a junk head, so you can experiment with different porting, you know, flow benching, and then you would spend, you know, $5 or $6 grand. You know, there isn't an off-the-shelf solution because building these things hasn't been too popular until recently, so you can't buy a pre-CNC ported head or anything. So, you know, like you're gonna have to do your own development. You know, we can help you. You know, we know the right people that can get it done, but it's not going to be cheap. So bang for the buck. This would be one step. Next step would be simple common sense porting. And then beyond that, you're spending a lot of money for maybe diminishing returns. I think one of the key things where we get a lot of power is we use these Jim Wolf technology cams. Now, Jim Wolf has really scienced out the valve train. What they've done is they use a lifter off of a VQ engine, you know, Nissan's V6, and that's like a one-piece lifter that's, you know, this little nub on the inside is select fit, and Nissan makes a whole bunch of different sizes of these and with different nub heights, and that's how you set your valve clearance. Now the KA engine comes stock with this kind of lifter that has a select fit shim that goes in there, and you put different size shims, and you know that's how you set your clearance. But one thing, it's a lot heavier. Two things, it's 2 millimeters smaller. So this is your cam rubbing surface, and you know with the VQ, your rubbing surface goes all the way out to the edge. Now 2 millimeters doesn't seem like much, but it's enabled Jim Wolf to really make their cams have a lot more area under the curve. So what I'm talking about is when you plot the area that your valve is open per degree of crankshaft rotation, you know, the Jim Wolf cam has a big old fat curve with a lot of area, so your valve is open for a longer time and more, you know, for the same amount of duration. So duration is what gives you the choppy idle and the poor bottom end, but area under the curve is what gives you the power. So by going to the larger VQ follower, Jim Wolf is able to grind their cams with a lot more area under the curve, a lot higher velocity ramps, faster opening, faster closing, and this gives you more power and torque per given degree of duration than any KA cam on the market. You know, we're running their biggest grind. You know, it's not too crazy because the amount of craziness that you could put in the cam is limited by this size, but it's about the biggest cam on the market. And I would say, I forget the exact amount of degrees, but it has probably about 40% more area under the lift curve over every other cam on the market with the same amount of duration. So I think, if you're going to be building a serious KA, Jim Wolf is the only way to go. Now, if you look at the cam, it has a nice lustrous finish, and that's from WPC treating. Now, you probably hear us talking about WPC treating a lot, and it's Japanese, I guess, micro shot peening treatment. It's not a coating. A lot of you guys think it's a coating when I see in the comments, but it's actually you're like bombarding the part at high velocities with a really almost microscopic ceramic ball that's perfectly round. Now, when you look at it, it looks like talcum powder, but what it does is it gives like a dimpled compressed surface like shot peening, and it gives a compressed stress skin over the part just like shot peening, and it refines the grain. So think that you're giving a hard, super smooth, fine-grained surface over your metal part. It doesn't change the dimensions or anything. The micro dimpling retains lubrication, and you're mostly running on the peaks of the dimples, so your surface friction goes way down too. Now, we have a lot of content about how WPC works, so look at our videos, do a search and learn more about it. But we really like this process. We find it reduces friction quite a bit, and it doubles the life of anything that rubs. So we WPC treated our cams. When you run Jim Wolf cams, you have to run their valve springs. The reason is the Jim Wolf valve spring, the resonant frequency of the spring is designed to match the resonance input of the cam lobe, so you don't have any critical frequencies that can cause spring surge or valve float. This enables Jim Wolf to control the valve train with a much lower spring tension than your typical aftermarket cam. This means less friction to turn the cam, less heat developed by the valve train. The valve train can generate quite a bit of heat, and longer wear of all the components. So don't just put your some random aftermarket dual valve spring in with your Jim Wolf cams. You're going to get rid of a lot of Jim Wolf's engineering. Match them with their springs. Another important thing is Jim Wolf has adjustable timing gears, and they also have a cam card with your cam. They're the only ones that make adjustable timing gears for the KA24, and you'll be able to degree your cam in precisely to what Jim Wolf says. And this is one of the reasons why a lot of engine builders, their engines are soft. They just throw the cams in and put them straight up. But, guess what? Tolerances and blocks and everything and the crank position is different with every motor. You rebuild your motor, you deck your head and you deck your block. You align bore the block for the crank, and guess what? All those distances change. Everything gets shorter. Your cam gets more retarded, and you lose a lot of power. So, like degree in your cam every time and use adjustable timing gears. It's one of the reasons why our motors run good. We take the time to do that. A lot of domestic builders, they're just used to doing something like, I run all my cams 4 degrees advanced from straight up, but they don't bother to degree them in. That's a big mistake, and I think a lot of amateur builders lose a lot of power and power band by doing that. The adjustable timing gear also enables us to optimize the cam lobe center for the type of motor. Now, this is a naturally aspirated motor, so we're probably going to want to run the lobe center kind of tighter, probably something like 108, 110 degrees, and split the overlap between the intake and exhaust. Now, this is a turbo motor. We'd probably spread it to like 114 or something. That helps build more cylinder pressure and prevents you from blowing the boost out the exhaust port on overlap. So that's another trick that works pretty good. Let me see. So we went over the head, the valve train, and now the bottom end. So the bottom end, the KA24 has a reasonably strong bottom end. Has this stud girl that ties all the main caps together. That helps stiffness. The block is cast iron. It's reasonably strong. The space between the bores isn't the greatest, so you probably shouldn't try to shoot to the moon for boost. Probably keep boost in the low 20s tops. Also, there's some weird things with resonance that happens with the KA block. Now, a lot of you guys are probably going to say I'm full of shit, but when I was at Nissan and with Nissan Motorsports, we broke a lot of blocks in NA KA24s. Now, there's some kind of weird resonance that the engine hits about $8,000, and it causes the block to split in half right where the parting line of the caps are. So right about here in the block, the whole bottom part of the block breaks off. Now, this is racing, like in GT3 or in the off-road trucks. I think it was class 7 or something, and they're revving the engines to 9. And I mean, this is brutal racing, revving to 9 all the time. And the blocks would break there. And a lot of people don't believe me, but if you rev the crap out of your motor, it's going to happen. So, my opinion is to build the motor to make power below 8, then, it's happy, and keep your boost below 20, and everything's happy, and everything will live a long time. And this is a pretty stout iron motor. So, you try to run more than 20, you're probably going to blow the gasket in between the cylinders. And they don't really make a good head gasket for these KAs. Like probably the best one is the Cometic or the Tomei, and it's a 3-layer MLS embossed gasket, which is all right. I prefer a folded stopper layer, but nobody makes one. I think SCI or somebody makes a copper gasket, but I really don't like copper gaskets for street cars because no matter what, like you'll see guys in the comments going, "Oh, I spray copper coat in my copper gasket and I run it for years. It doesn't leak coolant one bit." And I go, "Well, you know what? Maybe that's you." But, we machine everything really flat and put a good RA in our surfaces. Even do a little bit of lapping. Like that's that kind of white frosted look here. And, like a copper gasket will seal combustion pretty good, but your engine will always consume a little water, at least in my experience, and you'll always have that little whiff of coolant. It's not going to be pouring coolant out, but it's not going to seal up tighter than tight. So, like if the car's going to be driven on the street, or, it's not a race motor and you want it to stay together for like 10 years or something, I really don't recommend copper. So a lot of you guys have your own opinions, but that's mine. I've never been able to get a straight up copper gasket to seal the coolant perfectly 100% of the time. So I don't know. Like they have some new generation copper gaskets that have molded in silicone O-rings around the coolant passages and stuff, and molded in stainless steel O-rings around the bores. And I can't wait to try one of those, but they don't make it for this engine. So I think you're stuck with either a stock Nissan gasket, which is a composite, regular stock crap gasket, or a 3-layer standard MLS from Cometic or Tomei. So this one's going to get a Cometic, I think, which should be okay as long as it's naturally aspirated, compression's reasonable, nothing's going to happen. The stock crank on the KA24 is stronger than hell, and you never have to worry about anything happening to it. We just run it straight up stock. We don't build these engines to rev higher than 8, so you don't have to worry. This thing is not going to break. I mean, you can throw a boost at it, and it's going to be just fine. This crank, we balance it, and we WPC treated the journals, so you can see that milky, lustery surface. That's going to reduce friction. It gets in the fillets and adds a compressed layer there, so you get some fatigue strength. But that's all we do to the crank, and that's all it really needs. Like a Honda crank, it's a really good part. For connecting rods, we're running Manly. Now, I think Manly makes a hell of a rod for the price. Like, I can't believe what a good deal these are. We're running the optional ARP 2000 bolts. Now, Manly has their own bolts, and they have ARP 2000s as an option. I'm the kind of guy that always overkills the bolts, so I recommend the ARP 2000 bolt option. It's a really nice rod. The workmanship on it's good. We WPC'd the rod and bolts for some more fatigue strength and to get a little bit of lubriciousness in the small end bushing. So WPC'd. This rod has like 2 oiling holes on either side. Now, a lot of rods have the oiling hole up and top, but I really like the oiling hole down in kind of like in the groove here. I feel like up here is the really highly stressed part of the rod, and down here running 2 smaller holes is a stronger way. Now, there's plenty of high quality rods that have the hole up here, but I kind of think that that's a nice free detail that helps the strength. And yeah, I mean, if I was to design a rod, I'd do it like that. Now, don't get me wrong, there's some really high-end rods that have the hole here, but to me, here is better. It's the rods are it's machined from a billet, and it's shot peened, and on this particular one, we WPC'd on top of it. For the bottom end, you've probably heard my thing about not liking to use studs on the bottom end of a car if it's aluminum block because of the difference of expansion between the unyielding super strong stud and the aluminum block. Well, the KA is an iron block, so you don't need to worry about that. Now, an aluminum block, I'm always a proponent of running the stock stretch to yield bolts unless you need it. So unless you're going big boost or something, run the stock bolts, I always say, when it's an aluminum block. But an iron block like the KA, studded, why not? So on our motor, we're running the ARP main studs. Now, I don't feel that for an NA motor that these are 100% necessary. For a turbo motor, sure, but hey, it doesn't hurt, and it's iron blocks, so you're not going to have any bad side effects from it, potentially. Anytime you increase the torque over stock, you really should get the block align board. So, we have the studded bottom end, and then we align board it because higher torque means potential distortion, and you don't want to start assembling your engine and find that it doesn't spin anymore. So, yeah, this thing has been align board. Now, the ARP studs come with their forged bolts, forged nuts, and their ground washers. You should always use the ARP nuts and washers with their studs. It's important because they have the proper thread form, and the washers are perfectly flat, so you get super accurate torque. The washers are also hardened, so you don't have to worry about the nut digging into the surface and messing up your torque reading. And when using ARP hardware, always use the ARP lube. It's critical, and follow their instructions exactly. So with the studded bottom end, everything's going to be really solid. Don't forget align boring, like I said. Moving on, for bearings for this particular motor, we're running ACL. Now, we usually run King, but I think like King was out of stock on bearings for this particular engine on back order. ACL is also a really good bearing. It's a tri-metal bearing, so it has your steel backing, Then it has a layer of bearing material that's a really high percentage of copper. Um, this is a hard substrate that supports load and helps your load bearing capacity. Then it has a layer of softer bearing material that has a higher, I'm not like a higher lead percentage and less copper, so it's softer. So you have some forgivingness and some embeddability. And then you have a flash zinc layer on the final, the top, which kind of helps your break in. So this design gives you way more load bearing capacity than stock, and it also gives you some forgiveness with a slightly soft, very top layer. Now we WPC our ACL bearings. Now WPC has data that an OEM did, and it helps the bearing load capacity by 15 or 20% with nothing else done. It seems like magic, but some big name OEMs have done this testing with two different brands of car and motorcycle, and they both had the same result. So hey man, it doesn't hurt. We've never had a WPC treated bearing fail yet, knock on wood. If you can get 20% with just like a surface treatment, heck, go for it. Now, main bearings, WPC treated. Oh, sorry, rod bearings. Main bearings, WPC treated, and the thrust bearings. Now, I really like how it looks on the thrust. Now, like the copper thrust surface, you can see it has that milky, smooth WPC texture, and somehow I think that's awesome. I don't have any objective evidence that it's awesome, but I just think it is. For pistons, we're running JE's shelf piston. JE makes an excellent shelf piston for the KA. It uses their FSR forging. If you guys have been watching our videos, you know I love the FSR forging. And this happens to be an asymmetrical version of the FSR. So that means the thrust surface is wide, so there's a lot of support, more surface for bore stability. The non-thrust side that's not loaded is narrow, so it's lighter weight, less friction. So you get the best of both worlds. You get support, bore stability, less weight, less friction. Being an FSR, it's a strut type piston with a cut down pin boss with struts. This means it's a lightweight piston. It's pretty strong. It has undercrown milling. The skirts are coated. This little spot is so when you measure your piston to wall clearance, it's not coated. So there's a spot on either side of the coating. For rings, it runs a low friction, low tension ring package. There's a pressure equalization groove. It's a pretty exotic piston for the price point, and being a shelf piston, it's a really good value for the money. I mean, I'd have no problem rocking this on anything. Like, it doesn't have all the esoteric racing bells and whistles, but for this kind of motor, it's a pretty good piston. I wouldn't have a problem racing these. For alloy, it's 2618. It's a low silicon alloy, so it's tough. It can take some detonation and abuse. 2618 is like the strongest piston alloy that's commonly available. And like I said, incredible value, really nice piston, really good price. For the piston pin, you got a straight wall steel pin. It's not an ultralight taper wall. Like, I really don't like using those in too many different things. This is a great piston for a max effort NA motor or a moderate boost motor. Like, if you're trying to get 1,000 horsepower, yeah, this thing isn't thick enough. But the whole engine's not thick enough, if you know what I mean. So I think for our intended purposes, this is a great piston pin. Not too heavy, not an overkill, not under belt. For our ring package, like I said, we're running a low tension ring. These rings are pretty thin. I think it's a 1.1 and 1.2 millimeter. 1.1 for the top ring, 1.2 for the second. I'm just talking off the top of my head, so I think I'm right, but it's close enough. Top ring is made out of steel, and it's nitrided. The nitride is a super hard coating. It's designed to take heat, punishment. The top ring gets the most load, so the nitriding helps prevent galling and sticking in the ring groove. To me, this is a pretty state-of-the-art ring. The number 2 ring is like a steel, and it's phosphate coated. What's interesting about the number 2 ring is it has a Napier profile. Napier profile kind of has a hook on the sealing face, and it's like a really thin feature. And so this gives a really thin riding surface. This reduces friction, it improves seal, and since it has a small area, it breaks in really fast. So you get your hard top ring that lasts a long time and can take punishment. The second ring has the Napier profile, has a really thin section, so it breaks in fast, gives a good seal. Now, this thing kind of wears in, and it doesn't wear out quick, but it breaks in quick. The thin area has a good point loading, so the seal is going to be real positive. It doesn't have a lot of tension, so the friction's low. The oil ring is like a pretty narrow profile and really low tension. Typical what's state-of-the-art nowadays. But overall, it's a really good ring package. And there you have it. It's a pretty straightforward build. This thing probably will put out about 200 horsepower NA on pump gas. That's not too bad. It'll be a nice, pleasant, torquey motor, and it'll probably live a long time. Just don't rev it past 8 all the time, and it'll be great. And there you have it. So if you're interested in our content, you like what we're doing, please subscribe. If you got some time, go to MotoIQ.com, which is our online web magazine. We have thousands of tech articles on there. You can probably read about anything or learn about anything there to a really high degree. We have a web store there, so you can get our parts and everything. Please patronize us, because that helps us get money to fund more of this content. So if you like this KA24 stuff, we're going to be doing more, so stay tuned.